Hey everyone, welcome back. All right, this is class 3 in our 1B algebra class. Today's objectives, we are going to look at factoring. So we did a recap on adding, subtracting polynomials, multiplying polynomials, and now we're going to look at the beginning of factoring them. And we'll start with binomials, so two-term expressions, and then we'll eventually build up to trinomials in the next class. We'll also add in difference of two squares today. This is one of our special case polynomials. It kind of fits in here because it usually ends up in binomial form, and I want to make sure you guys can recognize it and find your factors from it. So questions for today: what does it mean to find the greatest common factor? And then how can I recognize when those difference of two square situations are popping up? All right, so you've got the factors of a value are the expressions or numbers that multiply equally originally. Like if you're talking about factors of something, what numbers will multiply to be the original value or whatever it is we're trying to find? So if I'm asking you for factors of 36, I'm asking you what numbers multiply to be 36, and they have to be whole numbers. So I'm not saying like a half times 72 or something like that. Like we're looking for whole numbers. They can be positive or negative, which is important. So factors of 36, I usually like to start with 1. And the number we have to check is if you take that number and put it inside a square root. So if you look on your calculator, you'll find the square root symbol. And when you calculate it, you'll get a number. So in this case, it is a square number, which means there is a square root. So 6 is an even number that comes out. But say like we did the square root of 39, for example. It would be 6 point something, something, something. So we would know that I need to check at least 6 if it's a factor, but I don't have to check 7. So that would be my cutoff point, so before 7. But that means for 36, I need to check all numbers up as far as 6, because 6 is the square root of 36. So 1 times 36. If I'm checking 2, I'm taking 36, dividing it by 2, and seeing what do I get. 36 divided by 2 is 18. 36 divided by 3 is 12. 36 divided by 4 is 9. 36 divided by 5 is not a whole number, so we say that's not a factor. And 36 divided by 6 is 6. So these are my factor pairs. So each line here represents a pair. So pair of factors, two numbers that multiply to equal 36. The negative numbers are also in here. So I could do minus 1 times minus 36, minus 2 times minus 18, minus 3 times minus 12, minus 4 times minus 9, and minus 6 times minus 6. So if I multiply the two of those, I will also get positive 36. If it was a negative 36, then one of my factors is positive, the other is negative. And you have to go through the whole list of both options. So give it a shot quick. I have 6 examples here for you. What are the factor pairings for each of these? So what you should do is write them out in a little set parenthesis and then close it after each pair. So for example, 1 and 27, close it. 2 is not a factor. 3 and 9, close it. And then for these positive numbers, I don't need you to write out the negative factors right now. Just know that for each one, there are going to be negative factors available. So pause the video, go through each of these, write out your factors, and then come back and see how you did. Okay, so for 5, the only factors are 1 and 5. 5 is what we call a prime number. Its only factors are itself and 1, and then you've got the negative version as well. For 18, we've got 1 and 18. 2 and 9. And 3 and 6, and then all the negatives that go with that as well. For 96, we got 1 and 96. So just kind of a little side note over here, square root of 96. Square root of 100 is 10, and square root of 81 is 9. So it's going to be somewhere between 9 and 10. So that means I need to check at least up to 9. I don't have to check 10 because it's bigger. So I would have like 96, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I would check all of those numbers to see if they're factors. So 1 times 96, 2 times 48, 3 times 32, 4 times 24, 5 is not a factor, 6 times 16, 7 is not a factor, 8 times 12, and 9 is not a factor, because 9 would go into 99 or 90, so it can't go into 96. So those are my factor pairings. So now I'll just write them out in my list. So we got 2, 48, 3, 32, 4, 24, 6, 16, and 8, 12. All right, for minus 30, I'm going to erase over here because I want to show you this one. Okay, so minus 30. We want to think about square root of 30. Square root of 25 is 5, square root of 36 is 6, so it's going to be, we're going to check up to number 5. But then we're also going to have to account for the negative versions of these, so minus 1, minus 2, minus 3, minus 4, and minus 5 as well, because you need a negative times a positive to equal a negative number. So we'll have 1 times negative 30, 2 times negative 15, 3 times negative 10, 4 is not a factor, 5 times minus 6. Now it's just going to kind of switch over, so now these are all going to be positive. So 30, 15, 10, not a factor, and 6. So when we do our pairings, we've got 1 minus 30. It's a terrible set bracket, apologies. 2 minus 15. 3, 10. 4 was not, so we got 5 minus 6. These are all terrible set brackets. Minus 5. We got, after 6, 10. And minus 3. We got 15 and minus 2. And then we got 30 and minus 1. All right, so those are all our factors of 30, or negative 30 in pairs. Next up, we got negative 42. The square root of 36 is 6, square root of 49 is 7, so we're going to test up to number 6. And then we'll have to do the negatives as well. So minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. So 1 times minus 42, 2 times negative 21, 3 times negative 14. 4 does not go into it because 4 goes into 40. 5 does not go into it. 6 times minus 7. And then just the other way around. So 42, 21, 14, no, no, and 7. So then you write out your pairs. So we got 1 and negative 42, 2 and negative 21, 3 and negative 14, no 4, no 5, 6 and minus 7, 7 and minus 6, so we got 14 and minus 3, and 21 and minus 2, and then 42 and minus 1. Sorry, my list got a little messy there, but you get the idea. Listing out your pairings. Okay, so find the greatest common factor. Same thing we just did, finding factors of a number, but we're also going to do it for a second number, and then we're going to look at the two lists we create and see what is the largest factor that appears on both lists. So our two numbers in this case are 16 and 84. So factors of 16, 1 and 16, 2 and 8, 3 is not, 4 and 4. So 16 is a nice easy one to do. 84, we got 1 and 84. The square root of 84 is going to be 9 point something, 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 so we're going to have to go all the way down to 9. Actually, we only have to go up to 8 because, actually no, we do have to go to 9. 9. Okay, 9 is not though, because 9 times 9 is 81, so we know it's not going to be that. 8 goes into 80, so it won't go into 84. 7, we'll have to get there. So 2 times 42, 3 times, so let's see, 3 times 14, so 3 times 28 is going to be 84, yep. 4 times 21, 5 is not. 6 times 14, and then 7 times 12. Okay, so there's my factor pairs. And the greatest common factor, so it's not 16, it must be, oh wait, it's not 8, never mind. So it's not 8, 4 is common to both lists, and that looks like it must be our biggest one. So we would say the GCF of these two numbers is 4. Okay, I want you to try now. You've got two numbers given to you. I want you to find the GCF of both numbers. And remember, if there's no common factor that's like larger than 1, then the greatest common factor is 1. So pause the video, try and find the greatest common factor of the two values, and then come back and see how you did. All right, so 14 and 26. 14, factors of 14, we've got 1 and 14, 2 and 7. 26, 1 and 26, 2 and 13. So 2 is the greatest common factor of these ones. 13 and 39. So we got 13 and 39, 1 and 13. That's it, because 13 is a prime number. 1 and 39, and 3 and 13. So 13 is common to both. 13 is my greatest common factor. 24 and 40. So we got 1 and 24, 2, 12, 3, 8, 4, 6. And that'll be as high as we need to go. 1 and 40, 2 and 20, 3 is not, 4 and 10, 5 and 8, 6, 7, nope, that's it. Greatest common factor is, I see 8 on both lists, so yes, must be 8. So I think a common mistake people make there is to put 4 and not realize, oh, there's actually 8 is a bigger one. And we got minus 15 and minus 44. So for minus 15, we got minus 1 and 15, 1 and negative 15, 3 and negative 15, minus 3 and positive 15. For negative 44, 1, negative 44, 2, negative 22, 3 is not, 4 and negative 11, 5, 6, no, 7, no. So that's going to be it, and then just the opposite. So we'll have minus 1, 44, minus 2, 22, and minus 4, 11. So my GCF in this case is actually 1. So there's nothing else common between them. So we would say 1 is the greatest common factor. When that happens, so when the greatest common factor between two numbers is 1, this is what we call co-prime. So they're not prime numbers, but compared to one another, they don't share any factors except for 1, so they're what we call co-prime. All right, so now when you've got letters involved as well, it's basically the same thing. One way to visualize this is that if you have any exponents, to separate them out. So 12, for example, is 12 times x times y, and 15 is 15 times x times x. So there is one copy of x common to both. And then you have to do GCF of the two numbers, so 12 and 15. So 12 will be 1 and 12, 2 and 6, 3 and 4. 15 will be 1 and 15, 3 and 5. So 3 is my greatest common factor. So I have 3x is my GCF for these two values. So there's a 3 common to both and an x common to both. All right, give it a shot on these ones. Pause the video and then come back and see how you did. All right, greatest common factor of 15 and 35 is going to be 5. And then x cubed is x times x times x. X squared is x times x. There are 2 copies of x that is common to both, and there's an extra one in the first one. So we're going to have 5x times x, which is x squared, is my GCF. 12ab squared and 48b squared c, or bc squared. So we got 12 and 48. 12 times 4 is 48. So the factors that we're going to be looking for are 1 and 12. And for 48, it's going to be 4 and 12. So 12 is going to be my greatest common factor. And then AB squared is ABB, BC squared is BCC. There is one B common to both, and that's it. And then for number 3, 16F squared GH. So we need 16 and 20. So 1 and 16, 2, 8, 4, 4, 1 and 20, 2, 10, 4, 5. So 4 is my greatest common factor number-wise. And then we got f squared, FFGH, and we got f cubed, g squared. So we got an f common to both, another f, and one g. So it'll be f squared g is my GCF. That last one was a bit more tricky for sure. There's more to follow and track. So if you didn't get it, try and look at what I did, see can you make sense of why that's now the GCF, and use it going forward. Okay, this is kind of like what we're really trying to build up to, is now we've got expressions, so polynomials or binomials or trinomials where there's addition subtraction between the terms. And we want to factor them. And we're going to factor them by removing the GCF. So when you have two terms like this and you're asked to factor, that means take the greatest common factor out and then have a parenthesis with what's left. So greatest common factor of 6 and 8 is going to be 2. There's no letter variable common to both, so we're going to put our parenthesis up. And then you have to put your remaining terms now. So 2 times what is 3x. So 2 times what gives me 6x, and that would be 3x. I think I said 3x in my warm-up there. I gave it away. Sorry. And then you're going to have 2 times what is 8y. That's going to be 4y. So my answer is 2 times 3x plus 4y. When you're done, you should notice that inside the parenthesis, there is nothing else common. There's no common factor between the numbers or the letters. That's how you know that the number you've pulled out is actually the GCF. All right, let's try a different one. 4x squared minus 14x. So we got 4 and 14. So 1 and 4, 2 and 2, 1 and 14, 2 and 7. That's it. So 2 is my greatest common factor number-wise. And then I've got x squared and x. There is a copy of x in both. So 2x is my greatest common factor. 2x times blank is 4x squared. That will be another 2x. 2x times blank is minus 14x. That will be minus 7. So my answer is 2x times 2x minus 7. So the 2x on the outside is your GCF, and then what's inside the parenthesis is your remaining terms. So this is what was left after you took out that greatest common factor. All right, take a shot at it with these ones. Pause the video, come back, and tell me how you did. So 5a cubed minus 3a squared, 36x squared plus 45x cubed, and 9 minus 21g. All right, so we got 5a cubed minus 3a squared. So 5 and 3 are both prime numbers, so there's going to be nothing common between those. So it's just going to be 1. And then a cubed is a times a squared is a times a. There are 2 a's common to both, so that is going to be my greatest common factor. And then what's left, I'm going to have a 5. I need another a, because a squared times a will be a cubed. And then just a minus 3 for the other one. For the second one, 36x squared plus 45x cubed. Greatest common factor for 36 and 45. Now you may not have to write this list out all the time. Like you might just be like, yep, I can see what it is. I understand what's going on here. For some of us, it's not as simple as that. You do have to do this check for quite a bit before you're like, I know my factors so well that I don't need to do this anymore. So we got 5 and 9. And that's it. So 9 appears in both lists. 9 is my greatest common factor for the numbers. And then I got x squared and x cubed. There are 2 x's that I can match in both terms. So I'm going to have 9x squared. What's left over? 9x squared times blank is 36x squared. I need a 4. So 9 times 4 is 36. And I don't need anything else because there's already x squared accounted for. Plus 9 times what is 45? That would be 5. And x squared times what is x cubed? I need another x. So there's my factored form. Third one, 9 minus 21g. 9 and minus 21 are my two values. 1 and 9, 3 and 3. 1 minus 21, 3 minus 7, 7 minus 3. And 21 minus 1. Greatest value on both lists is positive 3. So we'll take the 3 out. 3 times what is 9? It's 3. And then 3 times what is minus 21? It's minus 7. And then I also need a g. So this one's an important skill, being able to pull the greatest common factor out of two terms. If you can do that, you've got a great start to a lot of the questions that we are going to have. All right, this is one of our special scenarios. And the only way to get good at this one is to practice recognizing it. So we are going to be looking for binomials that fit this format. So a squared minus b squared. And the hard part is that the b squared part, or the last term or one of the terms, is not always going to be rewritten in this form. So you're going to have to keep an eye out for things called square numbers. So square numbers are numbers that when you do the square root of them, you get a whole number answer. So for example, the square root of 1 is 1. The square root of 4 is 2, so 4 is a square number. The square root of 9 is 3. So the other way to think about this is, what's 1 squared? 2 squared, 3 squared, 4 squared, so 16. 5 squared is 25, 6 squared, 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, 10 squared, 100, 11 squared, 121, 12 squared, 144. So if you don't have this list of numbers written down somewhere, I suggest you write it down, because your square numbers are going to be really helpful to you when trying to answer these sorts of questions. So the top line are your square numbers, and then the bottom line is what the square root of those numbers is. So we're going to need to rewrite in our question down here, x squared is already in that format of a squared, but 4 can be rewritten as minus 2 squared. So now it's x minus 2 to be squared. And the factors are going to be x plus 2 and x minus 2. So it's going to be that last number added and subtracted within the factors. So we'll do a lot of practice on this. Okay, so if we're presented it in this format, we got to think about 49 is a square number. So we're like, yes, square number 49 is the same as 7 squared. So I want to write it in that squared format. So we're going to rewrite this as a squared minus, and then in parentheses, 7 squared. So now I have this scenario of an a squared minus a b squared value. So in its factored form, it's going to look like a plus b. So a plus, and that b value is 7, and a minus 7. So that is my factored form of this one. All right, for this one, 16x squared minus 36. So we've got the lead coefficient is also a square number, which doesn't rule this out in any way. Now we can look at 16 and 36 and we can say, you know what, there's a greatest common factor thing going on here too. So I can divide both of these by 4 and take that out. So I'll have 4, and then what's left will be 4x squared minus 9, which I should do. I should always take the greatest common factor out first. And then I look at what's left in here, and I'm like, okay, 4 is a square number, and so is 9. So again, alarm bell is going off. This is probably a difference of 2 squares scenario. So I've got 4 times. Now 4x squared is the same as 2x to b squared. So if I square that, I will get 4x squared. And then minus 3 squared. So that gives me 4 times 2x plus 3 and 2x minus 3. So that format for writing difference of 2 squares. This is a harder one, particularly when both terms are square numbers and you have to rewrite them. So practice it a couple of times, do this a couple of times from start to finish, and make sure that you're doing the practice problems later as well. Okay, in this one, 3x squared minus 48 on the surface, 48 and 3 are not square numbers, so you're like, oh, there's nothing really to do here. But you can take out a greatest common factor of 3, which leaves you with x squared minus 16. And then you're like, oh, there's my square number, 16. So this is 3 times x squared minus, and then in parentheses, 4 squared. So really my answer is x plus 4 and x minus 4. So watch out for that one. Take the greatest common factor out first, then see is there any square number stuff going on, and then apply your difference of 2 squares. All right, your turn. Try these 3 out. In class, we did like a whole 40-something problems that were a mixture of everything we did, so that was the practice we did in class. But for you, practicing these 3 is enough to at least get you started. So pause the video, come back, and see how you did. Okay, so x squared minus 100, that is x squared minus 10 to be squared. So that means my factors are going to be x plus 10 and x minus 10. 9x squared minus 25, that is 3x to be squared minus 5 to be squared. So that would make my factors 3x plus 5 times 3x minus 5. And then 18a squared minus 8y squared, I've got a common factor of 2. So I take 2 out and I'm left with a 9a squared minus 4a squared minus 4y squared. So then now I've got 9 and 4, which are both square numbers. So this is going to be 2 times 3a to be squared minus 2y to be squared. So this one's got a double kind of squaring situation going on. So my final answer will be 2 times 3a plus 2y times 3a minus 2y. Hopefully you did all right there. If you didn't, go back, watch the setup again, and just keep practicing, guys. If you go on to Khan Academy and search for difference of 2 squares, you'll be able to practice these over and over and over again. Okay, essential questions. What does it mean to find the greatest common factor of 2 terms? So that means breaking each number down into its factors and identifying the largest factor that appears on both lists of factors. And then for variables, how many copies of each variable are in each term, and then pulling that out as your greatest common factor as well. Recognizing difference of two squares, you're looking for square numbers. So start training yourself, what are square numbers, and then if I can find them, can I check and see, is it a difference of two squares situation? So rewrite it as something squared minus something squared. So that's what the difference parts mean. Difference is the when two numbers are subtracted. All right, I will see you all next time.